Hi everyone. Today we'll be discussing the LeetCode problem of the day. Make array elements equal to 0. So initially you're given an integer array nums. So on this nums, you have to start by selecting any starting position such that the current value is 0. And also you have to choose a movement direction, which is either left or right. So suppose you have this array and let me just write the indexes 0, 1, 2, 3, 4 and 5. So you have to first choose two things. First is the current and next is the direction. So and also you only have to pick the current where you have the value as 0. So only these 3 points I can choose as the current value. So let's say I have chosen my current as this. So current will be 4. And let's say direction I have chosen as left. So you can either choose left or right. After that, after choosing current and direction, you have to repeat this following process. So first thing, if the current is out of range, then the process ends. So initially current is at 4. So at some point, if current reaches here or current reaches here, which is out of the array, you stop the process. Next, he says that if number of nums of current is 0, then you have to move in the current direction by incrementing current if you're moving to the right or decrementing current if you're moving to the left. So suppose you're currently at 4 and your direction is left. Since my current number is 0, you have to move in the direction of left only. And since you're moving to the left, current will decrease. So you move to the left, current will decrease and become 3. And suppose if you're moving to the right, then current will become 5 because current will increase when you move to the right. So that means when you're at 0, you just have to follow the flow. If your direction is left, you have to move to the left only. So that is for the value 0. Else if my nums of current is greater than 0, then you have to decrement the value. And after doing that, you have to reverse the movement direction. So left becomes right and right becomes left. After doing that, you have to move one step in that direction. So suppose initially I'm at 4. Since my element is 0, by following this point, I will move to the left. So my current will become 3. Now here also my value is 0. Again, I'll follow this point number 2, and I'll move to the left. And since I move to the left, my current will become 2. So now my current is at index 2. And since the value is greater than 0, now we are in the third scenario. So first what you have to do is you have to decrement the value by 1. So this 2 will become 1. After that, you have to reverse your movement direction. So currently we are moving left. So now left will become right. And after doing this, you also have to take a step in your new direction. So since it is right, I will again move one step to the right. And since I'm moving to the right, my current will increase. So current will be 3. And this is where this step stops. And after that, again, you're at 0. So again, you'll repeat the process by seeing the point 2. Since the direction is right, you'll again move to the right. Again, it's 0. Then again, you'll move to the right. Now here, if you see, you have a 3. So you will reduce it by 2. You will again flip the direction. So it will become left. Then you'll again move to the left and stop here. So your current is at 4. Now after that, again, you'll repeat the process. So the process stops only when your current will either go to -1 or either it will go out of the array. So you keep repeating the process until the current goes out of the bounds. And at the end, he's saying that a selection of initial current and movement direction is valid only if the total array will become 0 at the end of all the process. So after doing this process, at some time, your current will go out of bound. And when that happens, if all the values of the array are 0, That means the chosen current and the direction is a valid choose. And you just have to return the number of possible valid selections. So also note that current equal to 3, directions equal to L is one choice, and current equal to 3, directions equal to right is a different choice. So these both are considered as two different choices, even though current is same, but the directions are different. So let's just quickly look at the examples. So in the first example, we have 1, 0, 2, 0, 3. And he's initially starting with current as 3, which is this position, and direction equal to left. So initially, let's say current equal to 3 and direction equal to left. Now let's do the simulation. So you're at 0, you'll move to the left, and then since it's a non-zero number, you will decrease, and again you'll move to the right. Then it is again 0, you'll move to the right, then you'll decrease, then move to the left. It's a 0, so move to the left. It's a non-zero, you will decrease again, and again you'll flip it. Again 0, again you'll move here, and you will decrease this. And since you have decreased it, you will again flip it. So you'll move to the left, you'll move to the left. This time this value is 0, so you keep moving, and here it's a 1, so you decrease it and make it 0, and again flip it and keep moving to the right, and here you will make it as 0, and again flip the direction. So you'll move to the left, 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 and at this point you will move to the left, and you'll see that your current is going out of the array. So you stop the process, and as you can see at the end of the process, all the values in the array are zeros. So that means current equal to 3 and direction equal to left is a valid choice. We can also say that current equal to 3 and directions equal to right will also give us the same result. So let me just do that as well. So 1, 0, 2, 0, 3. So this time we have current equal to 3, but the starting directions is right. So what happens, you start here, you move to the right, and this becomes 2. Then you keep moving to the left, this 1. Then again you keep moving to the right, 1, again left, becomes 0. Then again right, now this becomes 0. Again left, this becomes 0. Again right, and at this time your current stops here, which is out of the array. Now as the process stops, you can see all the values are 0. So this is also a valid choice. Now let's see invalid choice and see what happens. So notice that you have another 0. So you can pick this one as well. 1, 0, 2, 0, 3. And let's say in this case, current equal to 1, and let's say direction equal to right. So initially I'm starting here, I'll move to the right, so 2 becomes 1. Then I'll move to the left, then left, 1 becomes 0. Then right and right, this 1 becomes 0. Then left, left, and left. Now I'm out of bounds, so the process stops. So the final array is 0, 0, 0, 0, and 3. But we can see that all the elements are not 0. So this is not a valid choice. You can similarly see that even if we start with c equal to 1, directions equal to left, still we'll get the same result. We won't have all zeros. So for this input, we can have two starting configurations. So the output is 2. Now let's quickly see for the last input. Here we have 2, 3, 4, 0, 4, 1, 0. So here he's saying that there are no possible valid selections. So suppose if we start at this 0, if we choose the direction as right, immediately you will go out of bound. And even though if you select left, you'll go to the left, you'll make this 0, and then you'll again turn back, you'll move to the right, again it's going out of bound. So this 0 is not a valid selection. Now we can choose this 0. So suppose if we take the initial direction as right, so first it'll go to the right, this 3, then it'll go to the left, 3, then 2, 2, 1, 1, 0, 0. After this, it will move right, 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 and this will become 0. Then again, it will move left. This will be 2. Then again, it will move to the right, and here it will go out of bound. So here we can see that the final array is not all zeros. So this is also not a valid configuration. Even if you choose left as the starting index, you won't get all zeros. So for this input, the answer is 0. And the array size is at max 100, and each element's value can be at max 100. And it is also guaranteed that at least one element in the array will have a value 0. So that means you can always choose a starting point. It can either be a valid or not, but you can always choose a starting point. Now let's discuss the approach. So suppose you have few values, 0, 0, and then 4, then 5, and then 2, and maybe 1, and a 0. So this is your array, and you have to choose a starting point, which is a 0, and you have to choose a direction. So you can think of this as you have a few stones lined up. So initially this stone weight is 1, this stone weight is 5, and here we don't have any stones. Then we have a stone of weight 4, and then you have a stone of weight 2. And initially you are launching a ball to either left direction or to right direction. So if you initially start at the left direction, so wherever it is 0, it just keeps moving forward in the same direction. So this ball keeps moving forward, and once it hits this stone of weight 5, so what happens is it will break the stone a bit. So that means the stone weight was 5, now it will become 4. And since the ball is hitting this stone from this direction, after the collision, the ball direction will change. So ball will hit here, it will reduce the stone's weight by 1, and then it will flip the direction. So that again it will travel and it will hit the next closest ball. So again, when it hits this stone's weight will be reduced by 1. And this ball keeps moving. It goes left, it goes right, it goes left, it goes right, as long as it stays inside the array. So at some point, let's see what happens. So first it hit here, it became 4, then this became 3, then again it will hit here, so this becomes 3, so it will hit here, this becomes 2, then this becomes 2, this becomes 1, and this becomes 1, and yeah, now when the ball is coming from here to here, the stone weight is 1, and the ball hits this stone, the stone completely breaks off, so the stone weight will become 0. And then since this ball hit the rock, it will again change the direction, and it will move here, and it will hit this stone, and this stone also the weight is 1, so the weight will become 0, and it will flip the direction. Now when you come back, you see that here the stone weight is 0, so the stone is completely destroyed. So the ball passes this and hits the next stone, which is the stone number 2. So from this, what we can figure out is, suppose we have a stone of length 5, weight 5, and a stone of weight 5, equal weights. Let me take a small example. Let's have a stone of weight 2 and a stone of weight 2. And we have a ball initially here. If we start moving it in a direction, it will hit here, and it will hit here. Then again it will hit here, again it will hit here. So if both the weights of the stones are equal, then what happens is, first this weight will become 1, then it will hit this, so this weight will become 1, then this weight will become 0, and this weight will become 0, and after that this ball will go out of bound because all the stones are destroyed. So one thing we can say is whenever we choose a starting point, if my sum of all the values in the left is equal to sum of all the values in the right, then I can choose any starting point, any direction of the point. So I can either start with the left or I can also start with the right. If I start with left, it happens like this. First 1, then 1, then 0, then 0, and the ball goes out of bound. And if I choose right, so first this will become 1, then this will become 1, then 0 and 0, and the ball will go out of bound. So one thing we can say is if the weights are equal for this particular starting point, you can choose any of the direction, left or right. Now let's see another condition. Suppose my weight is 2 and here my weight is 3. So the difference in the weights is exactly equal to 1. So in this case, what happens is if I start the ball with left as the starting point, so what happens? First it will hit here, this will become 1, then it will hit this will become 2, then it will again hit this becomes 0, then it will again hit here, it becomes 1. So after this, the ball moves this way, and since there is no stone here, the ball goes out of bound. So this is our final array. So we can see that this stone is not completely destroyed. But instead, what happened? Let's see what happens if we start with the direction of right. So ball starts here. So this will become 2 first, then this will become 1, then this will become 1, then this will become 0, and this will become 0, and then ball will go out of bound. In this case, we can see that the entire array became 0. So from this, what we can say is if the difference of the weights is exactly equal to 1, then you can only choose one direction, which is if right side has the more weight, you have to choose right as a direction. And suppose if this is 4, this is 4, then you have to choose left as the direction. So you can't choose right. In that case, the stones won't be completely destroyed. So we have seen two cases where weight of left equal to weight of right, and another case where weight of left equal to weight of right plus 1, or even weight of left plus 1 equal to weight of right. These both cases are like similar. That means the difference of the weights is at most 1. And finally, we have another condition where weight of the first stone is suppose 4 and the weight of the second stone is more, like maybe 6. So in this case, no matter what direction you start, by the time this stone gets destroyed, this stone still remains. So let me take a small example for this. Let's say 3, and let's say 1. I choose a ball and starting direction is left. So first 3 becomes 2, then this 1 becomes 0, then this 2 becomes 1. But after this, the process stops. So here we can see that if the difference between these two stones is greater than 1, then no matter what we do, we can't completely destroy the stones. So based on this observation, all we have to do is just check the array 1 0 2 0 3. So suppose this is my starting point. From here, I just have to know what is my left hand side total sum and what is my right hand side total sum. So in this case, the left hand side total sum is exactly equal to right hand side total sum. So I can choose any of the starting points. So either left or either right. Now for this, my left hand side sum is 1 and my right hand side sum is 5. So one stone is size 5, another stone is size 5, one is size 1 and the next is size 5. So the absolute difference is greater than 1. So no matter what direction we choose, we can't destroy all the stones. So in this array, the total answer is 2. And let's quickly see what happens for the second input. We have 2 3 4 0 4 1 0. So suppose if we pick this 0, we have the left sum as 14 and the right sum is 0. So you can't pick this 0. Now what about this 0? You have the left sum as 9 and the right sum as 5. So again, no matter what direction you pick, you can't completely destroy the left side stone. So for this case, the answer is 0. So now the only thing we need to see is for each of the 0, we just need to find the left sum and the right sum. So one thing we can do is whenever we have a 0, you just run a loop on the left side to get the left sum and run a loop on the right side to get a right sum and just compare it. If left is equal to right, then increase the answer by 2. And if the absolute difference between the left sum and the right sum is 1, then increase the answer by 1. So by this approach, we will get the total complexity as order of n square. And since n is small, it will pass. But we can use prefix sum concept to get the left sum and the right sum in constant operation. So let's quickly discuss that before going to the code. So I'm just generally explaining the prefix sums. So we have index 0, 1, 2, 3, 4, 5, 6. And you just build a prefix array of this, where prefix of I denotes sum of all the values from index 0 to index I. So prefix of 0 is 0, prefix of 1 is 0 plus 1, 1, prefix of 2 is sum of all the array from index 0 to index 2, which is 3. And here you will have 6, then 4 plus 6, 10, 5 plus 10, 15, 6 plus 15, 21. So if you pick any index, suppose if you pick 4, the prefix of 4 denotes my sum of the array from index 0 to index 4. So if you add up all these values, you'll get the answer as 10. And to build the prefix array, you can use this formula, prefix of I equal to prefix of I minus 1 plus array of I. So this is how you build the prefix array. And now from this prefix array, you want to get the left sum and the right sum. So suppose I am at index 3 and I want to get my left sum and I want to get my right sum. So to get my left sum, I can easily say my left sum equal to prefix of I minus 1. So this is my I. This will be my I minus 1, and prefix of I minus 1 will give you sum of all the indexes from index 0 to index I minus 1. So left will fetch all this sum. Now to fetch the right, it is not completely straightforward. So for right, what we can do is, if we say prefix of n minus 1, prefix of n minus 1 will give you the sum of the entire array. So prefix of n minus 1 gives you the sum of the entire array, which is the entire part. But out of this, you only want this part, which is the right sum. So from this entire sum, you have to somehow subtract this part of the array. So you can easily get the sum of the green part, and that you can do it by prefix of I. So prefix of n minus 1 is the entire blue part. Let me write it in red. And let me write this as in blue. Yeah. So prefix of n minus 1 is the red part, which is the sum of the entire array. And from that, you're subtracting prefix of I, which is sum till here. When you subtract this from this, you'll get the blue part, which is the right sum. So this is the left sum and this is the right sum. And you just compare. If left is equal to right, then just apply the logic we discussed before. Now let's quickly code the approach. So first I'll take int answer equal to 0. And I'll just iterate. So first I'd like to code it on with the brute force approach. So we'll start iterating less than n I plus plus. Also n equal to nums.length. So now we want to get the left sum and the right sum. So we'll take left equal to 0 and right equal to 0. Now to get the left sum, we'll just iterate j equal to 0, j less than I, j plus plus, then left plus equal to nums of I. Now to get the right sum, we'll iterate from I plus 1 to the end. So j equal to I plus 1, j less than n, j plus plus, right plus equal to nums of j. I think this will also be nums of j. And now you got the left sum and the right sum. So now you'll just compare. If left equal to right, you can choose any of the starting point. So in your answer, you will add 2. So 2 denotes starting point left and starting point right. Now you have another case where the left and right differs by at most 1. So I can take math.abs left minus right is equal to 1. So if the difference is at most 1, then I can only choose one of the direction. And else you don't add anything, so we don't need to write it. At the end, let's return answer. Okay. One more thing we've missed is we can only do the operation if the current value is 0. So first we have to check if nums of I equal to 0, then only we can choose that particular point. So if my current value is 0, then only I'll calculate the left sum, I'll calculate the right sum, and if left is equal to right, then increase the answer. And if absolute difference is at most 1, then answer increase by only 1. Let me test now. Okay, but yeah, it works. But now let's just quickly transform this into a prefix sum. So currently the complexity is n square, outer loop n, and inner loop is also running n. So to transform it, let me first quickly initialize a prefix array. And prefix n, prefix of 0 will be nums of 0, and for remaining numbers, prefix of I equal to prefix of I minus 1 plus nums of I. So this is how we have formed the prefix array. After that, you can directly get the left sum and the right sum. So let's see. Left, you can directly get it by doing prefix of I minus 1. And the right, like we discussed, first get the whole array sum. From that, subtract prefix of I. So by doing this, we are completely skipping these two for loops. And if left equal to right, you just increase your answer by 2. But here there's a corner case because you are getting left equal to prefix of I minus 1. And what if the value of I is 0? Then this will go out of bound. So if I equal to 0, that means if my I is at here, my left sum is obviously 0. So for that, we can say that if I equal to 0, then my left will be 0. Otherwise, my left will be prefix of I minus 1. So left, right, and then just applying the logic. So this will have a complexity n plus n. Let me test it. Okay, and let me submit. Yeah, and it works. Finally, let's discuss the time and space complexity formally. So for time complexity, we are running a loop to build the prefix array in order of n. And again, we are running a loop to calculate the elements starting positions. So total complexity will be order of n. And for space complexity, since we are creating an array of size n, the space complexity will be order of n. I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.